introductory one from last year, and they even have one on, setting up Slurm, like some lectures. So where did yeah, introduction to Slurm. So right, there's like slides, and there should be I think there's hands-on like lab sort of stuff where they show you how to actually configure it somewhere. I think I saw it. It's in one of these lectures, but that would be like, I'm not a Slurm administrator at all. I went to one of these cluster institutes once, and did the basic setup myself. It was like 5 or 6 years ago, so I don't really remember. I mean, I know some of the details of like how Slurm works, but and how you would configure it. But if I was learning how to set it up myself and start from scratch, this is kind of where I would go and start doing that. So that would be like my recommendation for anyone doing the system administrative side of the cluster, and if they wanted to try to set up Slurm, this is where I would go. Other than the standard Slurm documentation, that would be those be my two resources, I guess. So just keep that in mind. Try to clean up my screen a bit here.
No, I'll probably save the chat just so I can keep that link.
Yeah.
Because yeah, that's something that I looked at in the past, because I did want to get the system early, and I did want to put Slurm on it. So yeah, this is kind of interesting to me.
Cool. Okay. Yeah. I just couldn't remember if we've talked about this in previous years. But that's like a nice resource from like actually setting things up on the system, beyond this, the application software. So yeah, I think in the training schedule, Mary put a link to this interactive training video. Like, so this is just a talk that I gave on, if you're new to working with Slurm, basically explaining what it is and how to get started working with Slurm. So you can definitely go back and find a bunch of stuff in the like this in the the SDSC training catalog. There's slides. I mean, it's really basically an overview. It's not a whole lot of hands-on showing you how to use Slurm. So that's kind of what I'll show you today. Just, I think in terms of this question of like, if you don't have Slurm on a cluster, how do you start sort of modeling how you'll run these applications, on a system like Expanse, sort of ignoring Slurm, other than sort of using it to, ask for resources and start running jobs with MPI manually. But feel free to go through these videos. Hopefully they'll be helpful if you want to understand some of the concepts about Slurm. But I think in terms of the competition, if we don't have a cluster, we don't have a scheduler like Slurm to help integrate the initialization and startup of your MPI jobs, this is how you can start sort of manually getting on the system and playing around with some basic MPI jobs. Because so next week, I guess, on the schedule is you will be having a lecture from Mahi and maybe Elham, it looks like, on the schedule about MPI and OpenMP. And so if you want to bother them with more questions about how to run sort of more complicated MPI jobs manually on Expanse or other systems, please bother them next week, since I wasn't really sure exactly what to talk about for today, but I'll show you a few things here. Right. And so I'm going to log into Expanse. So does everyone have access to Expanse, Francisco? I assume so. Yeah.
I think everyone should. If they
Okay.
don't, then they can just message me, and they get added like in 3 days or
Okay.
something.
Well, again, if Slurm's available on the other system you guys have access to, it should be fairly similar, right? So right, so if you're not familiar with Slurm yet, I mean, right, it's just the batch job scheduler that manages like any sort of resource requests that you want from a supercomputer like Expanse or an HPC cluster like this HPC fund cluster you've all been talking about. So in this example, what I'm going to do is not run a direct batch job script for you. I'm going to show you how to start an interactive session on a couple different nodes and run a simple like hello MPI world job, manually across those nodes that we now have access to by making the request through Slurm. So, usually when, I'm working on a system like Expanse, I'm usually writing batch job scripts to Slurm to just submit the script and sort of execute all of the commands that I would want to do on the system, right? For example, like let's see if I can find a quick HPL command or HPL.
Marty,
Yep.
what is the maximum hours you can allocate an interactive node on Expanse?
So essentially, usually on any HPC system, right, there's no difference really between a batch job and an interactive session when it comes to the request you can make. So for example, you can request, nodes just like any other, like all of the partitions on Expanse are typically 48 hours. So you can request an interactive session for 48 hours if you so choose. Right. So let's see. Let me just find a script here real quick. Right, so this is what my complicated, I guess, HPL naming, script naming looks like. But, essentially, right, usually when most people are submitting jobs to a Slurm scheduler, this is kind of what that looks like in terms of the batch, uh, script way. So this would be taking the script and submitting this script to the scheduler with the sbatch command, which is the way you would submit a job script like this. And every job script has, it starts with, after the sort of specifying the, interpreter or shell that you're going to use to interpret the script. You have a set of directives. So these are the Slurm directives or the sbatch directives that you would apply when submitting the job to the scheduler, right? Or basically, it specifies, different properties about the job that you need to tell the scheduler, right? So usually I always start out with like a job name just to label the output files. You have an account that you usually need to charge the job to, right? On Expanse in most systems, this is usually your Linux group that you're working with or that you have on the system is usually how most systems organize what the job charging account is. Sometimes, Slurm is federated in different clusters, so you can actually have multiple clusters on the same scheduler, but that's not too important. The notion of a partition is important, right? So any system that you're working on, there will be different Slurm partitions. And this is how the scheduler will organize different sets of resources usually that are available to you. So for example, if I go to the Expanse user guide, right, and go down to the running job section, you'll see a table here that sort of lists the different partitions that are available on Expanse presently, right? Or at least the ones that are documented in the user guide here, right? So you can kind of see here, I'm selecting the compute partition here, which allows you to run for a max of 48 hours, like I just mentioned. You can have a maximum of 32 nodes in any job. You can have a maximum of 32 jobs running and 64 queued at any time. And this, just tells you kind of what it's meant for. So essentially, when you run any jobs on Expanse in the compute partition, you get exclusive access on a per node basis, right? So you basically will allocate jobs that you want to run per node. So if you want a single, so this is, for example, a single node job, right? on the system, right? But if I wanted to say run HPL across 2 nodes, I would set this parameter equal to 2 nodes. So that would make sure that the scheduler knew that I want 2 nodes allocated for this job to run, and I'm going to run, my application across both the nodes, right? And so, but on Expanse, we also have things like the shared partition, which is focused on, jobs less than a single node. So essentially, their users are usually requesting like how many compute cores they want, or like maybe they only need like a single GPU, so that we have these GPU shared partitions, right? So anytime you get on a system like Expanse or maybe this HPC fund, right, and it's running Slurm, there's going to be different types of partitions that are available, and the resources you want to request to run your application, you need to sort of match that to the right partition, right? And so the basic command for investigating like what partitions are available on a Slurm cluster is the sinfo command, right? So if you just run sinfo, right, it basically lists the different partitions and sort of their various nodes that are assigned to that partition and their states, essentially, right? So, anytime you're learning a new piece of software, you always want to, check out the documentation. Slurm documentation is pretty good, so I'll just put that, that's one command that you can use to start investigating the different partitions, and, oh, shoot. Okay, sorry, my screen went blank. I've had problems in the past with Zoom crashing on my new setup here, so hopefully we're going to be good for the next 10 minutes or so. Okay, so yeah, that's, in a very important thing that you need to remember when requesting resources. Now, let me just go back here to the SBatch directives. So when we want to run a multi-node job, right, we're going to change this node parameter to at least 2. Maybe I'll do in our example here. The other parameters you'll see usually specified in at least Expanse's job scripts, right, are the n tasks per node. So, right, this parameter is usually what you will want to set to the number of MPI processes per node that you want to start, right? So this is, what, people always ask what this parameter is for. It's like, well, usually the tasks, when you're running an MPI application, will correspond to the number of MPI processes per node, right? And so that's going to be, the setting that you'll want to use here in, when you're learning to use Slurm on a system like Expanse. Whereas this next parameter, the CPUs per task, are usually what you want to set the number of OpenMP process threads to, right? So if you have some MPI hybrid threaded application, usually the number of threads in that shared memory model, programming model you want to use is usually set to the CPUs per task, right? So essentially every process gets assigned an X number of CPUs that you can then use per process, you use that threading within each MPI process, and that's the number of CPUs that you have assigned to that process, right? And then there's an overall memory parameter per node that you'll usually set, obviously, how much time you need. The output parameter here, or directive, is just how you will, this is the name of the standard output file, essentially, right? So if you look at the Slurm documentation, right, this %X and %O, %J, %A have special meanings, right? The %X just says I want to label my output file with the job name, the job number, or the job ID number, if you're running array jobs, which we won't get into. But anyway, these have special meanings to just use information that I've specified about the job to label the output file, which is super important usually when you're running on systems, especially it sounds like you'll be running on maybe shared systems and shared accounts, right, on your cluster. So you don't overwrite other people's files, right? So if you all name the same output file for the same job every time you run it, right? If you're running your benchmark, and you want to go back and debug, you want to make sure every time you run your application that you have some mechanism for specifying a different output file so you can save the work as you go and debug what's going on with the application, right? Of course, if you don't have Slurm on your cluster, you have to sort of do that manually. We can talk about in the future, like, some environment variables you can use for that. But that's why this is sort of complicated. So I always don't overwrite my output file and still have it labeled in a systematic way with more information than maybe that I actually need, but it's good to be sort of pedantic there. Okay, so this is a job script, right? But if you don't have a cluster, right, how do you start, or if you don't have a scheduler on your cluster come competition time, how can you start practicing how to run MPI applications now, right? And that's by starting an interactive job, right? So this is my job scripts. Right? So I would submit the scripts like that to the cluster, and I can check my status of my job, or this is an array job, so 20 different HPL jobs, right? With the SQ command is the other command that you'll want to learn to check your jobs when you start working with Slurm. That's always the most important question people have, like, is my job running? But there are two other commands that you might not have used yet on Expanse or this AMD cluster, and they are salloc and srun. And they can be used sort of together, where salloc essentially allows you to make the resource request to Slurm to allocate the nodes for you, right? But this is, you're not actually requesting any sort of commands to be run, like as all of those commands you saw in my job script would run after those sbatch directives, right? Right. After the sbatch directives, everything after the last sbatch directives are different shell commands that I want to run, right? That lead up to eventually me running HPL down here in a container, right? Whereas salloc and srun, salloc will allocate the resources on the system for you, and srun you can then use as a way to execute commands in that allocated set of resources. Or, as you'll find in the Expanse user guide, usually what we recommend when people are starting out with interactive jobs is simply running srun to request an interactive session on the resources you want to use, right? So if I take this single srun command, right? Essentially, what it's saying is we want to, let me just clean this up a little bit. I'll put it in the chat. So essentially, you'll notice that the different flags here are all very similar to what you saw in the example batch job scripts, right? So I'm basically reorganizing this a little bit like it was in the job scripts. That's it. I run, instead of the S batch command, I have S run the account that I have to charge the job to. Then I select again what partition I want, the number of nodes, the number of tasks. I can even add CPUs per task here. Just do one. The amount of memory, how much time. And then you have a little bit of special options here that have to deal with, essentially you're saying, I want to run at this command, which is just start a bash shell on those resources, right? And I want it to be interactive. Is this what this PTY is here? So if I run that command, right? Right. All it does is drop you into an interactive session on that node, right? So this is just one of Expanse's debug nodes in the debug partition. So yeah, what my suggestion would be is to, on Expanse or this other system, start playing around with salloc and srun, because at the end of the day, right, if you want to run MPI commands manually instead of through a scheduler on the competition cluster, right, you can practice it through interactive sessions like this, right? And so let me go ahead and show you what that might look like, right? So here, I think I can request 2 nodes. Just going to do 1 task per node, 1 CPU per task on each node. So basically I'm requesting 2 nodes, right? But I only want 1 process per node. And I want to try to run some basic MPI job from this interactive session, right? So if I do an SQ, you'll see here I've been allocated resources across 2 nodes, right? So in theory, if I load, some MPI module that we have on Expanse, I should be able to run a simple MPI job across both of these nodes within the 2 processes, essentially slots that have been allocated for me, right? And now, right, you can kind of ignore that you even have Slurm on the system, right? So this is how you can start practicing how to run these jobs manually, right? So let me try to do this real quick. And it'll be a really dumb example, but I'll show you where you can find some other examples to try to repeat this exercise with a more complicated example. But I'm going to do a module load. Let's see, GCC. And that's kind of like the usual standard GCC and OpenMPI that we use on Expanse right now. Okay, so I should have access to MPI run, right? Now, let's see, if I do MPI run, hopefully, I don't think this is going to have the Slurm integration by default. So if I do an MPI run, n equals 2, that's 2, I want to start 2 MPI processes. And if I run as my MPI program hostname, again, which isn't too interesting as an MPI program, but in theory, if we then, this is it gonna hang? Okay, so I know why this is happening. So a lot of NPIs, when you build them these days, or have Slurm integration inside. And so, but you can't run an srun command from within srun. So I think what I need to do salloc. I think everything. If I do an salloc, everything should be the same, except you'll notice that it doesn't drop me into the node, right? So if I do an SQ, I still have the two nodes allocated, but I'm actually still on login 2. So what I would do is SSH in to the node directly now, the session, and let's see if I can retry this module load GCC 10.2. If I do an MPI run, it's still might not be the best simulation yet. It's probably gonna still try and use. Okay, no, it's not using it. Okay, sorry. I thought it might still try to use some of my Slurm environments. Okay, this is good. So if I do a, so you can see here, right? If you look at the output, right? It ran two MPI processes, but they were both on Expanse 955, right? And this is what you would get if you were doing this manually on your, one of the nodes in your cluster, right? So how do we run an MPI job across the cluster, right? So you're going to have to actually specify usually what's like known as a host file. So I forget the exact commands. It's been a while since I've done this manually myself. Let's see. Let's see. Help. Let's see. Host file. I think. So right. Okay. Yeah. So I think if I just write and I put spans 955 dot spans guys. So if I just manually provide the host names, I think this is going to work. Hopefully. Okay, so two processes. Need to give it a host file. So my host file.text, and I just want to return the host name. And so in theory, that did not work. Why not? Let's see.
Dash H, capital H, or that works too.
Am I forgetting something? Forget.
Oh, the program maybe?
Well, the program is just host name. Um, see, try force it equals to Let me try adding map my node. Well, this is a complete failure on my example. But this is the idea here, right? So you're actually trying to manually launch using only the MPI run commands across the two nodes that have been allocated, right? And let's see if we can figure this out real quick. Um, let's see the host. Um, okay, let's try the host list instead of the file. Maybe I've not formatted my host file correctly. Okay, so host should be a list. Where is it? List of hosts. So it's probably expanse 955. Well, yeah. Well, let's try this anyway. I'll show you something else here in a second. If this doesn't work, try one more thing. There were not enough slots available in the system. Don't know why it's not working. I have specified the number of slots even. Um, Under how does it even know what the number of slots are? I don't know. Okay, let's try. Well, The one other thing to think about on these systems too, especially when trying to practice like this on Expanse, is that there are multiple interfaces, right, for the networking. And one of the things I was just thinking of that, might be an issue here is that I'm using this fully qualified domain name, right? And if you look at if config commands, um, you know, the IP address for these fully qualified domain names is actually the public address, right? That's available on Expanse. Whereas you actually want to communicate over the InfiniBand interface on Expanse to get good performance, right? So what I should really be doing in terms of creating my host file, like manually, is using or trying to use this um, use this host list is actually probably giving it directly the IP addresses for the nodes for the interface on the IB card for the nodes that I've been allocated, right? And so I think this is usually they set up these IPs pretty nicely that you notice that 55 corresponds to node 55 uh, even on the management network, right? So, the system administrators are pretty smart to, be able to not have to remember random IP addresses for different interfaces. So I assume this is also the IP address for the Expanse 956 node that I've been allocated. I'm gonna try to run this again. I'm still skeptical it's gonna work for this issue. But this is, I guess, the strategy that I would, as you get started with MPI again next week, if you can figure out how to run this before next week, and I will try as well to figure out what my problem is. Uh, you know, this is kind of how you can start practicing these manual MPI runs, I think, unless there's something fundamental that I'm forgetting. Let's just check the IP address. Yeah, so right, that's the correct address. So yeah, um, this is kind of what you'll need to know how to do by digging through whatever version of MPI that you're going to put on the system, whether it's Open MPI or MBAPICH or well, I don't think AMD has their own implementation. So it's probably going to be OpenMPI and or MBAPICH. These are sort of the options in the MPI run commands that you're going to want to start digging through and figuring out how to manually set that up on a system. And yeah, that's kind of all I have for today until I have time to go back and debug what I'm missing here on the OpenMPI side. Any general questions, comments, concerns, or you can just tell Paco like I really want Slurm set up so it's not this hard.
For me, this is easier. I learned this first, so
Okay, yeah, uh, yeah, because like if I do just right with the salloc command, right? The nice thing about having Slurm. So if I have salloc here, I should just be able to, I think srun, I think it's J. Oops. And run a command. What is it? Uh, it's the option, not J. Let's see. Okay, switch real quick. Where is it? S Alec. Where- Give me an example. Human options. Uh, you can tell I don't use this too often. This one. They don't even explain it here well. Oh well. If I just do this. That's how easy it is. There's not even an option to choose the job. Right. So I'm on the login node, and basically the srun commands is basically running the command across both nodes. So yeah, there's my sleep command on one. Oops. Sleep command on the other. And it would be the same if you just ran an MPI run command, right? So it would automatically launch MPI run across both nodes and help do the wiring up, usually with the integrated MPI run with Slurm. So you don't have to do all that manual stuff. But it's good to learn. Clearly, I've forgotten some myself. So any other questions, comments, concerns?
Marty,
Yeah.
so I just have a like some question not related to running, but like underneath like how it works. So like does MPI API like uses infinity band like by default, or does it just use regular like Ethernet through the operating system?
So it will depend on your system configuration and the MPI distribution, right? So if I go back to my like one of my job scripts here this is with OpenMPI. It's a bit of a complicated question. I think I have it. No, I don't have it in here. There are so by default, right? MPI, OpenMPI. Oops, not loaded there. Let me see here. Right, if I load my OpenMPI module here, and this will be true if you're going to use OpenMPI on your system. Right, by default, OpenMPI uses UCX as part of its software stack now. And by default, UCX will auto discover all of the interfaces that it can communicate over, right? And it will try to use them when you run your MPI commands, right? Like we actually ran into this when we deployed Expanse. Like we didn't realize that that right? That by default, OpenMPI was using both the management network and the InfiniBand. So basically the standard like 25 gig Ethernet port and the InfiniBand. So we were getting like weird numbers. So it is something that you have to check and control for, depending on your MPI distribution. I forget, I think maybe Mbappage didn't auto discover both and like picked the preferred interface. But it is something to keep in mind, especially here when you're sort of, manually hacking together, like how do you force the communication over different interfaces, right? So you might have a management Ethernet port and the InfiniBand, right? And so you do need to be a bit careful there sometimes. Hopefully that answers the question.
Yeah, I see. I think that certainly answers a lot of my questions. Thanks so much.
Good too, because while we have the versions of MPI we've been using in the past have been custom built, and UCX was one of the things that has to be enabled. So I guess that's pretty good to know.
Yeah, so OpenMPI, right? The four, basically in the 4 series started basically, it being required. It wasn't like the whole 4 series, but it was basically, really early on, like essentially that by default UCX would be used. And so the 5 series I'm sure is UCX based as well, because there is 5 out now. I haven't played around with it yet myself. And I think with the Mvappage has released finally their base sort of, maybe it's their alpha or beta Mvappage 3, or maybe it's even production now, 3 series versions, and I think it's also fundamentally UCX based now too. So there might be if you were using Mvappage, thinking about using Mvappage between the 2 and the 3 series, there's this UCX transition too, I think. It might be interesting to try both out. So, like I said, UCX has its whole other set of options that you have to like think about sometimes too, right? So UCX, and environment variables and things in the documentation, right? Because it's kind of a sort of the communication runtime that the MPIs are based off of now, or sort of the framework at least. Right, so MPI sort of sits on top of UCX now, most of these MPI distributions.
I think I might take a look at that. Okay, cool.
Yeah, so yeah, definitely, like, if anyone is playing around with OpenMPI, it's probably built with UCX right now in whatever system you're using, like Expanse or maybe this other one, and you can actually, there's different environment variables, like the one with the interface. Forget which one we use. I mean, there's ones where you can actually force UCX to use different, network interfaces and things like that, and don't use the management network and things like that. So there's all sorts of environment variables that you can set for UCX as well.
Okay, cool.
Mhm.
Thank you, Marty.
All right. Well, it's a little late for me here, so I'm gonna run, but I'll try to do a quick write-up of what I tried to show working on Expanse today. Since I didn't quite get it working, I'll sort of, send you guys those notes once I figured out what options I actually missed in my little example here. And that'll probably hopefully be useful for when you talk about MPI again next week. All right. Well, thanks everybody. I'll see you next time.
Thank you.
Yep.
Thank you.
Hey, yo, Paco, you still here? Oh yeah, you are. By the way, so regarding that bank account thing, I currently have no leads. I messaged. So there's some dude. It was part of some kind of financial office in the school administration, and he didn't know, and so he recommended I